Welcome you all for Computer Aided Detailing of Structures Laboratory. In this session, I will be discussing about drawing and detailing of doubly reinforced beam. In case of doubly reinforced beam, tension reinforcement will be provided at the bottom and compression reinforcement will be provided at the top face of the beam. Here is a problem statement. Draw the longitudinal section and cross section of rectangular RCC beam 300 mm wide and 500 mm deep. Beam is simply supported with 300 mm bearing and having a clear span of 5.4 meter. Tension reinforcement consists of 4 numbers of 20 mm dia bars and 3 of 18 mm dia bars as compression reinforcement. Beam consists of 2-legged 12 mm dia bars as vertical stirrups spaced at 150 mm center to center near the face of the support up to a length of 1.5 meter and 300 mm center to center for the remaining portion. Here I'm supposed to draw two things. One is longitudinal section and another one is cross section. In longitudinal section, we had to show the length, depth as well as the reinforcement details. In case of cross section, we had to show the width, depth along with the necessary reinforcements. For longitudinal section, if you view the beam from the front, you can see the length as well as the depth. Let me draw the length of the beam for a span, including the clear span as well as the bearing on either sides. Since it is a simply supported beam, as per the problem statement, I have mentioned the bearing width of 300 millimeter on either sides. Therefore, we had to draw the beam for a length which includes a clear span of 5.4 meters and 300 mm bearing on either sides. Let me place the main reinforcement, that is the tension reinforcement, at the bottom face of the beam with a nominal cover of 20 to 30 millimeter from the soffit, which are of 4 numbers of 20 mm dia bar. And at the top, we are supposed to provide the compression reinforcement, which are of 3 numbers of 18 mm dia bar. Then it comes to the stirrups, which are of 2-legged 12 mm dia bar at 150 millimeter center to center for a length of about 1.5 meter from the face of the support on either sides. And for the remaining portion, we had to show the stirrup spacing for about 300 millimeter center to center where the shear force developed will be less. This is with respect to the longitudinal section. And to draw the cross section, I have to cut the beam and I have to view the beam from the side. Here I'm supposed to draw two cross sections, one near the face of the support and one in the mid portion. Let me consider cross section AA near the face of the support. Suppose if I cut the beam here and if I view it from the side, I can able to draw the width as well as the overall depth of the beam. Tension reinforcement consists of 4 numbers of 20 mm dia bars need to be placed at the bottom face of the beam with a nominal cover, say about 20 to 30 millimeter. And at the top, I had to place the compression reinforcement, which is of 3 numbers of 18 mm dia bars at the top face of the beam. Next, it comes to the vertical stirrups. Near the face of the support, stirrups are spaced at 150 millimeter center to center. I have mentioned the same. This is with respect to the cross section AA. Let me take up another cross section in the mid portion, that is BB. Suppose if I cut the beam and if I view it from the side, I can able to draw the width as well as overall depth of the beam. Reinforcement remains the same, only changes with respect to the stirrup spacing, which is of 300 mm center to center in the mid portion. This is with respect to the cross section BP. This is with respect to the longitudinal and cross section of doubly